Okay, hey everyone. In this video I will be solving a problem about inductor and magnetism flux, and I will explain every step as clearly as possible. So not just how to solve it, but also why we use each formula. This is a medium level problem from the homework 6, I think so. And let's read the problem first. The solenoid inductor has an EMF of 0.20 volt when the current through it changes at a rate of 10 ampere per second, and the steady current of 0.10 amperes produces a magnetic flux of 5 microweber per turn. Okay, we know these values, so we need to find how many turns does the inductor have. So let's start by writing out the known values from the problem. So we know the EMF is equal to what, and rate of change of the current is G delta I over delta T is equal to. The next is steady current is I is equal to ampere, the same is ampere, and the magnetic flux per turn so we need to convert we already write it. So next is we will do is find the inductance using by this formula. Delta I over delta T. So let me explain why we use this formula. Because when the current in a coil changes, the inductor resists that change and creates a voltage. That's what we call induced EMF. And this formula shows us the relationship between the voltage EMF and how fast the current is changing, and also how strong the inductor is. So we can rearrange the formula to solve L, like E over Ti delta I over delta T. So is equal to over let me calculate. The answer is about 2 henries. Okay, so we know the inductance of inductance is equal to 0.02 henries. The next step is how now we know the inductance. So let's move on the second part of the problem, finding the number of turns. So we know this formula. Let's write here first, then write second. L is equal to turn times flux over I. So, and let me explain why we are using this formula too. This formula shows how inductance is connected to the physical structure of the coil. The more turn you have, and the more magnetic flux each turn carries, the more inductance you get. So when a steady current flows through the coil, the total flux in cage is equal to N times F. So this is the perfect formula to find N. We already know other L, current and flux. So let's solve by the N. For N is equal to L times current over flux. So now plug in the numbers. We already know the values of all of them. Just let's write over Yes, 5 times. Okay, let's calculate it. I'm sorry, I think there are some mistakes. Okay, the answer is 400 turns. So let me do a quick recap for what we just did. First, we used the EMF formula to calculate inductance. Then we used the inductance flux formula, this formula, to find the number of turns. And then we already find the number of turns. Its final answer is n is equal to 400 turns. That's how many turns the coil has based on the EMF, the change in current, and the magnetic flux. I think we have time, so let's solve next equation. Here, let's first read and try to understand the given of the formula or given of the problem. The inductor in figure is a length of, okay, we know the length. Let me write together. Okay, L is equal to 9 centimeter. Let's change to the meter. Okay, diameter is equal centimeter diameter cylinder wrapped with 300 turns. Okay, we know the diameter. If you know the diameter, we also can find the radius. Radius is equal to diameter over 2 is equal to okay, let me write in meters. So we also know the turns. We know from the previous problem that how to write the turns. Turns is equal to y. So next is what's the current in the circuit 10 milliseconds after the switch is moved from the 1 to the 2. Okay, we know the time range is equal to 10 milliseconds is equal to 10 times 6 seconds. So by default we know that the resistance is R is equal to 3 ohm here, and the battery provides voltage or EMF is equal to 6V. So our goal is to find the current IT after 10 milliseconds. Okay, we treat the solenoid as inductor. The formula for the inductance of the solenoid is L is equal to over N. Okay, here mu is a constant, we all know. N is the number of turns. A is a cross-sectional area. How we write this? And the length is the length of the solenoid, we already know. So let's calculate by the area. L is equal to n quadrat multiplied PR square over L. So let's write all of them. 4p times 0 minus 7. It's a constant value, so then we know the number of turns. square times P. We know the value of R also. Okay. Over L. We know the value of L too. The final answer is 3.95 microhenries. So, okay, let's write it here clearly. Okay, we already defined the inductance. So next step is initial current before switch flipped. So we need to find initial current. We can find this by this formula. I think you all know about this formula. So we know the all values over 30 is equal to 0.20 ampere. So initial current is, we need these answers. So next step is, what happens when the switch changes its position? When the switch flipped to position 2, the battery is disconnected first. The second one is inductor and resistor form our closed loop, and the next is current start to decrease over time. Okay, this is model. Let's write the formula. Next formula. I see you know this formula. Minus over torque. Okay, it's initial current, and we know the initial current, of course. Time minus T is the time, and it's equal to L over R. So let's solve step by step. I want to solve it first. 3 times 95 times 0. Okay, we find it here. So over resistance is equal to 30. So the answer is times minus 4 seconds is equal to 132 microseconds. So the constant is like this. We know this, and just write the formula. Use it in our formula. Initial current we solved is equal to times E minus time is minus 10 micro. Yes, am I right? Okay, just over seconds, we just write like this is equal to okay. The final answer is microampere. It's after 10 microseconds. So we already find the answer. I think that's okay. Thank you for your So thank you for your watching. I hope this explanation helped you really understand the solution of two example. At first I shooted this example, and when during the process I understand that it takes only 5 or 6 minutes, so I decided to add the second problem too. Thank you for watching. I think I will help you to understand